Morning, friends. Welcome back to our class. And this is the last class from our fourth unit of MS. And then the next class will meet with the fifth unit of MS, right? Right. In the previous class, we discussed about the model of CPM network diagrams, right? So these are the previous slides in this problems we discussed, right? So listen carefully. Now we need to draw PET diagram. PET. So PET, project evaluation review technique or program evaluation review technique. Listen carefully. It was developed by US Navy Special Projects Office in 1957, right? So in this project evaluation review technique, also known as program evaluation review technique, is a project management tool used to schedule or organize and coordinate the tasks within the project. So schedule, organize, and coordinate the tasks within the project. It is basically a method of analyzing the tasks involved in completing a given project, especially time needed. Please listen carefully, time needed. So analysis the tasks based upon time needed to complete each task. So here, and to identify the minimum time needed to complete the total project. So the major goal of project PET diagram is here time needed, estimation of time needed to complete each task, and to identify the minimum time needed to complete the total project. This is the major theme of the PET, right? Project evaluation review technique. So in this project evaluation review technique, we used three types of timings. That is here, shortest possible time. That is called as here optimistic time. And most likely time means here normal time. And the longest time means here pessimistic time. So here we used three types of timings because we don't know the exact time for each and every activity. That's why we use these three types: short time, normal time, and the long time for each and every activity. And by using the formula optimistic time plus 4m means longest time plus 4 into normal time plus shortest time by 6. By using these three timings, optimistic time, pessimistic, and most likely time, and by using this formula, we can find a single estimated time for each and every activity. This is the major purpose of PET diagram, PET, right? So please remember and note this formula of PET, very, very important. Pessimistic time means maximum time, so longest time plus 4 into normal time plus optimistic time means minimum time, minimum possible time means the shortest time. So optimistic time plus 4 into normal time plus optimistic time by 6. This formula, right? This vector. So now we are entering to PET problems, PET network diagram, right? By using these three timings and this formula. Please listen carefully. Now we are entering to drawing a PET analysis, PET network diagram, right? By using these three timings. Right. Look at here. This is the example of project evaluation review technique. So here, these are the activities. And these are the activities names. Some of cases, these activity names not mention the problems in our problems. So just they give activities, this column, and just these three columns. Some of the question papers, these columns not mentioned in the problem, right? The exams. Look at here. Already just I told you that we have the three timings: optimistic time, pessimistic time, and the normal time for each and every activity. So based upon these three activities and formula, we can find out a single time for each and every activity. So that is the PET analysis. That is the simple technique of PET analysis, right? So look at this problem. These are the activities: 1 to 2, 1 to 3, 1 to 4, 2 to 4, 3 to 4, 3 to 5, 4 to 6, 4 to 7, 5 to 7, 6 to 7. These are the activities. So suppose here 1 to 2 activity having three types of timings. But this previous problems, 1 to 2 activity having only single estimation time. This previous problems also. So activities, preceding activities. Each and every activity has a single time, single estimated times. Look, just observe this all previous problems. Just activities, each and every activity has a single time, single time. But here in this pattern, they give three types of timings for each and every activity. For each and every activity, three times they give, because we don't know the exact time for activity. That's why they give short time, long time, and normal time, right? So suppose, look at here, look at here. First of all, 1 to 2 activity. So in this 1 to 2 activity, we have optimistic time 4 hours. Means this activity as minimum as short possible time, as minimum as possible time. That is called as here shortest time for 1 to 2 activity. Here 1 to 2 activity, TM means normal time, means the normal time required to complete this activity is here 6 days, right? This is normal time. And 1 to 2 activity, pessimistic time means here very longest time, as maximum as possible time, as maximum as possible time is here longest time for this particular activity. So 1 to 2 activity is here 4 hours shortest time to complete this activity, 6 days normal time for this completion of this activity, and 8 days for completion of this activity, the maximum longest time for completion of this activity. So that's why these all activities having different short times, normal times, and the maximum or longest times. So 1 to 2, 3, 1 to 3 activity having 2 hours short, normal time 3, and largest time 10 days. Suppose take this example of this 4 to 6 activity. So 3 hours short time, 5 normal time, 7 longest time. Suppose take the example of this 6 to 7 activity. This activity having 2 hours of short period of time, 9 hours normal time, and 10 hours maximum time to complete this thing, right? So like this, each and every activity having three types of timings: optimistic time, normal time, and pessimistic time. So shortest time, normal time, and longest time for each and every activity. So based upon this given data, draw the project network diagram and find the critical path, right? So based upon this activities, first of all, we need to draw network diagram. Network diagram. So like this. So 1 to 2. This is the one activity. This is the two activity. 2. So 1 to 2. By connecting these two by using arrow key 2. Right. Next 1 to 3. So this is the one already withdrawn. And next 3 activity 3. So 1, 2, 3 by using one arrow key to connect these two nodes, right? Next, 1 to 4. So this is the 1 and 4, connecting these two by using arrow key. Next, 2 to 4 and 3 to 4. 2 to 4 and 3 to 4. Here we have the 2 to 4 and 3 to 4. Just we should draw okay guys, so next 3 to 4, 2 to 4, just connecting these 2 points by using arrow key, right? And 3 to 4, just connecting these 2 nodes by using one arrow key. Next thing, 3 to 4, 4 to 6. Next, this is the 4th activity and this is the 6th activity, and connecting these two by using this arrow key. Next thing, 4 to 7. So this is the 4 and this is 7, connecting these two activities by using this arrow key. Next, 5 to 7 and finally 6 to 7. So 5th activity, 5 to 7 and 6 to 7, connecting these two with the 7th activity, right? And finally, this 2 to 4 and 3 to 4 connected, but 2 is empty. So by using this dummy activity for preparation of a logic diagram. So this is all about drawing a PET diagram. This PET diagram is look like a CPM analysis, CPM diagram, right? So now after completion of this diagram, then we need to calculate these 3 timings by using our formula. What is the formula? Optimistic time plus 4 into normal time plus pessimistic time by 6. This is the formula of PET, right? So by using this formula, we can calculate these 3 timings into a single time, average time, right? So look at here, the same problem will appear in this slide. So look here, 1 to 2, 1 to 3, these are the activities. So optimistic time 4 to 6 1 6 6. So to optimistic 4 to 1 6 6 6 like this. Next, normal time 6 3 8 2 7 7. Normal time 6 3 8 2 7 7 like this. Next, pessimistic time. So pessimistic time means largest time. So 8 10 16 3 8 14 7 12 6 10. So here mentioned pessimistic time 8 10 16 3 8 14 7 12 6 10. For these 3 timings already given in the data for these activities. Now that time expected for each and every activity is calculated by using this formula. Similarly, to expected time is calculated for each and every activity. So finally, by using these 3 timings and formula, we can find out a single time for each and every activities. Single time for each and every activities. For this purpose, we have this formula. Now coming to here. So first activity, look at here. 4 optimistic time plus 4 into normal time plus pessimistic time by 6. So here optimistic time is here for this activity 4 hours. So 4 plus 4 into normal time. Here this is the normal time for this activity 6. So 4 into 6 hours 6. Next, pessimistic time means longest time for this activity. So here 8 hours. So 8. So 4 plus 4 into 6 plus 8 by 6. So the formula, we have the 6 number So just by put this number here. So then we will get 36 by 6. So that's why 6 days of activity of A or 1 to 2 activity A, we have 6 hours of average time or single time, right? So then here we have 3 types of timings. By using this formula, we can find this single time, this average time for this activity. So same way, these all activities are calculated by using this formula. So next 1 to 3. So 2 plus 4 into 3 plus 10 by 6. Then we will get 4. Next 1 to 4 activity, optimistic time plus 4 into normal time plus pessimistic time by 6. That's why here 6 plus 4 into 8 plus 16 by 6. And the next 2 to 4, 1 plus 4 into 2 plus 3 by 6. Then we will get 2. Next 3 to 4, 6 plus 4 into 7 plus 8 by 6. Next 6 plus 4 into 7 plus 14 by 6. Then 8 average time. Next 4 to 6 activity, 3 plus 4 into 5 plus 7 by 6. Then we will get 5 average time. Next 4 to 7 activity, 4 plus 4 into 11 plus 12 by 6. Then we will get 10 of 10 estimation of time for this activity. Next 5 to 7, 2 plus 4 into 4 plus 6 by 6. Just I am applying this formula for this all activities right now. So then we will get 4. Next finally 6 to 7 activity, I am applying this formula for these activities. 2 plus 9 into 4 plus 10 by 6. Then we will get 8, right? So like this, we calculate these 3 timings into a single time by using this formula, right? Now, these timings mentioned in these activities. These timings mentioned in these activities. Suppose in this previous problem, 1 to 2 activity, they give only single time. So then this time mentioned in this arrow key, right? Between these 2 points. 4. Suppose 3 to 5 activity, we have 6 hours. So 3 to 5 activity, we have 6 hours. Just to mention this 6 hours of time in between these 2 nodes, right? 6 hours. And same way, we find these types of timings. These timings are mentioned in this diagram and between these nodes, right? Suppose 1 to 2 activity, we will find we have 6 hours of time. So 1 to 3 activity, just put here 6. So the 6 timing is put here 6. Next 1 to 3 having 4 hours of average time. So 1 to 3. So 1 and 3 just here put 4 hours of time. Next 1 to 4 we have 9 hours of average time. 1 to 4. Here 1 and 4 just mention here 9 hours. Here mention the 9 hours here. Next suppose take the example of 3 to 5. So 3 to 5 activity having 8 hours. So 3 to 5 activity having 8 hours. So just mention 8 hours here, right, in this between these 2 points. So like this, we can draw the PET diagram and calculate these 3 timings by using this formula and put these all timings for each and every activities in the diagram and then find the critical path methods, right? So this is all about PET diagram. This is all about PET diagram, right? So This is all about project management, CPM and PET diagrams. Just I want to overview of this all unit for 5 to 10 minutes, right? So project management. Project management is a set of tasks or list of activities, pre-decided list of activities to complete our total project, total contract. That is called as a project. For this accomplishment of a total contract within a duration of time, we should have the activities, preceding activities, dependencies of activities, estimation of time, estimation of cost, optimization, budget, next allocation of resources, input and output planning. These 9 activities are comes under here in the name of project management. Based upon these 9 activities, we can easily maintain our total project or our total contract. That is about project management. So here, the timing and controlling, strategies, monitoring, development, process, analysis, executions, and planning all comes under here in this project management. And next, the project management features. The project is maybe uniqueness. So simply every contract may be non-rotating, non-repetitive, non-routine nature, and it may be complex or simple based upon the nature of the work. Next, risk and uncertainties are there. Every project has a risk and every project has the uncertainties. And next, duration of activities may be uncertainty. Next, it should be complete within the deadlines. Next, we know about critical path method. So this is a network diagram. This arrow piece is called as here activities. This circle forms is called as here nodes or events. So total project calculation by using this network diagram, right? So from this network diagram will helps us to understand the each and every activities in easily, right? And understand the sequence of operations from starting point to finishing point. And each and every activity, we have the estimation of times, right? And this diagram, we can easily know the preceding activities, and the dependencies of activities. And another benefit from this types of network diagram is we can know the critical events and also non-critical events. So this is all about the network diagrams. So this network diagrams will help us to know the total project duration, the total contract completion time. We can easily know about this thing, right? So this is network diagram. So for this contracts, we have 2 types of network diagrams like this one. First one is CPM and the second one is PET. So in this PET diagram and the CPM diagram are the 2 techniques to know the total project completion times and the total activities and the total precedings activities, critical activities and non-critical activities, and the total project duration in a simple manner, right? That is the major purposes of critical path and PET diagrams. Next, coming to the CPM, the CPM was developed by DuPont company in the year of 1957, right? So this is all about critical path method. So in this critical path method includes each and every task should be necessary and dependencies of activities and necessary activities, estimation of time, and calculate the critical path, and planning, scheduling, and controlling of activities, and the stakeholders' expectations, allocation of the necessary resources. Resources means here 5 M's: money, men, material, methods, and the machineries. These are the 5 M's. So allocating and controlling of the resources, project plan with the project team. These are the few points are including in this CPM, right? The next earliest possible time, latest possible time, earliest finish time, latest finish time, floats, crash durations, and critical path. These are the few terms we should understand here. Already we discussed this, all things in the previous classes, right? So this is the network diagram. Already we discussed. These arrow keys are called as here activities. These circle forms are here nodes. So event or node based calculation is called as PET. Activity based calculation is called as here CPM, right? So characteristics of CPM already we discussed. Next, project evaluation review technique. This project evaluation review technique is used for very large, huge and non-repetitive contracts. Please remember this thing. Very large, huge and non-repetitive contracts in this PET will used, right? So here in this PET diagram, we don't know the exact time for each and every activity. That's why we use 3 types of timings: optimistic time, most likely time, pessimistic time. So normal time, so optimistic means the shortest time, pessimistic means longest time, for estimation of a single average time for each and every activity, right? And this PET diagram and PET technique is developed by US Navy in 1957, right? This is the formula of pessimistic time plus 4 into normal time plus optimistic time by 6. So this is the process to draw network diagram, PET network diagram, right? So importance of a PET system, need of PET or CPM, what is the use, what is the need to draw the network diagrams, and the limitations and the drawbacks of CPM and PET. And this is the major thing, difference between the CPM and the PET. This CPM is used for complex and simple projects, routine projects. But this PET is used for large scale projects and non-repetitive actions, non-repetitive contracts. CPM is based upon arrow keys or activity-based oriented networks. But PET is used for circle forms, nodal points. So nodal based, event based diagrams. So CPM, each and everything deterministic means pre-decided, each and everything. But in this PET diagram, each and every activity and each and every decision may be the probability is based upon the probability. So probabilistic means may chance to success or may be failure. It may be success or it may be failure. In the CPM, we can calculate and we can estimate time and cost both. But in this PET, only we can estimate time. Only time will be estimated in the PET diagrams. Next, in the CPM, we will have only single time for estimation of each and every activity. In this PET diagram, we don't know the exact time for each and every activity. That's why we use 3 types of timings. So we use 3 types of timings to estimate a single average activity, right? These 3 timings are optimistic time, pessimistic time, and normal time. Next, these are the CPM repetitive activities. PET in this thing, non-repetitive the activities. And CPM is used for construction projects. PET is used for research and development activities like innovations and inventions development processes. And already we discussed the project management process. So first of all, establishment of project management infrastructure by using these 3 things. and project definition. Simply identify the project objectives, scopes, and benefits, risks of a particular project. We should understand the objectives and targets, benefits and scope, and also understanding the risk analysis of the project, and develop implementation approaches and develop the resources plans. So simply develop the 5Ms plans here. And next, the third step is here, project plan. So prepare a detailed schedules of each and every activity and the resources and a time and cost estimation. These schedule, resource, time and cost estimations are comes under here, project planning. And next, project implementation and control. So here implementation is based upon our project plan, and controlling means the comparison between the actual performance with our planned performance. If gap is there, then we need to control and we need to take remedial actions to fill that particular gap. That is called as here controlling. So project controlling. And finally, close the project. Is that a brief discussion about project management, right? So and these are the few diagrams. Activity on arc. So just put the name of this activity, this arrow key arc, that is called as activity on arc. But put the name of this node, that is called as activity on node, activity on node. Next, already we discussed merge events and burst events. So 3 or 4 activities come from and connect with a single activity, that is called as a merging activity. So from one point to deviate 3 or 4 another activities, that is called as a merge event. Next, suppose take the example of J, this preceding activity and the after this activity is called as here succeed activity. Before this point is here preceding activity, preceding activity, activity, succeeding activity. So these are the few activities, and these are the few problems already we discussed, right? So we will end up this 4th unit Cpm and PET diagrams, right? So here we should remember this thing. Cpm and PET, the deviations between these two, and how to draw the network analysis and how to find the critical path, right? Critical paths. Okay, we will discuss it in the next class by 5th unit of MS, right? Thanks for listening, guys. Bye.